Hi and welcome back to another chemistry lesson with Mr. Simons. Atomic combinations and intermolecular forces, right? November 2019, question 2. Again, there would be Lewis structures and shape being tested, polarity, bond length. But this question, we've also brought in the graph of potential energy versus the distance of the nuclei. So very important that you know that question as well. So let's look at the questions. Alright, ammonia, NH3 and hypochlorous acid are both examples of covalent compounds, meaning they share electrons. Define the term bonding pair for 2 marks. So third definition, third question. Draw Lewis structures for the following molecules. So by now you see we're always drawing Lewis structures for 4 marks every exam paper. Now this one, we're not only asking lone pairs, but we also want bonding pairs. And then shape. Right, and 2.1.4, which bond NH or OH is more polar? Give a reason for your answer for 2 marks. 2.1.5, write down the type of intermolecular forces present in both ammonia and hypochlorous acid. Right, and then they say when ammonia dissolves in water, the ammonium ion NH4 is formed. What type of bond forms between the ammonia molecule and the hydrogen ion? So this is the first part of the question. The graphing question I'll do separately. So we're first doing 2.1 to 2.1.6, right? You can attempt to answer this before looking at the solutions that I'm going through. So bonding pair, 2 electrons, very important, shared between 2 atoms in a covalent bond, right? So it must be 2 electrons that shared between 2 atoms in a covalent bond, 2 marks. Lewis structure for the following molecules. So nitrogen group 5 has 5 valence electrons, 2, 3, 4, 5. Hydrogen group 1 valence electron, so therefore 1 from hydrogen there, 1 from hydrogen and 1 from hydrogen there. And that there then is my Lewis structure for ammonia. Alright, 1 mark for correct amount of valence electrons, second mark for correct shape. Hypochlorous acid, oxygen is my central atom. There's 2, 3, 4, 5, 6 valence electrons, right? Chlorine has 7 valence electrons, 2, 4, 6. Number 7 there combining with oxygen to form an octet there. And hydrogen 1, so hydrogen combining with the other one of oxygen there. It forms a linear shape, right? So 1 mark again, correct amount of valence electrons, second mark for correct shape. Now 2.1.3, write down the number of bonding pairs in NH3. So there we have 1 pair, second, third. So there's 1, 2, 3 bonding pairs. Yeah, hypochlorous acid, there's 1, 2 bonding pairs. Number of lone pairs on the oxygen atom in HOCl. So lone pairs, so there we have 1 pair that's alone. And there we have a second pair that's alone. So therefore we have 2 lone pairs on oxygen. Shape of the ammonium molecule. So this shape there that basically forms almost like a T. It's called a trigonal pyramidal shape, right? So there you need to go study your shapes. Right, let's go to the next questions. Which bond NH or OH is more polar? Give a reason for the answer. So in this case it's OH and we can work it out. So the change in electronegativity would be 3,5 minus 2,1, which gives me 1,4. Nitrogen being 3, hydrogen 2,1, 3 minus 2,1 gives me 0,9. So there OH is more polar than NH. So 1 mark for the correct selection and a second mark for showing that it is more polar. 2.1.5, write down the type of intermolecular forces present in both ammonia and hypochlorous acid. So ammonia is NH3, so there we have nitrogen combined. So nitrogen combines, then we have hydrogen bond. In hypochlorous acid we have oxygen. So when oxygen, nitrogen, or fluorine is bonded, then generally we're dealing with hydrogen bonds. So both of them have hydrogen bonds. All right. When ammonia dissolves in water, the ammonium ion is formed. What type of bond is this called? So for ammonium ion and for hydronium ion, they are referred to as a dative covalent bond, meaning the fourth hydrogen slips into an empty orbital or the extra bonding pair on top of nitrogen, and it combines them. All right. Now let's go look at the graph question. And so 2.2, they say the graph of potential energy versus distance between the nuclei of two oxygen atoms during bond formation is shown below. Right, so there we have two oxygen atoms. 2.2.1, over there on the y-axis we have my potential energy, and there we have the distance in picometers, 10 to the negative 12. Define the term bond energy. So again, definition. Which curve A or B represents the formation of a double bond, meaning oxygen, double bond oxygen, between oxygen atoms? Explain the answer. Write down the bond length of the bond represented by curve B. Right, so those two values there gives me bond length. The further the graph goes down, the more potential energy it got. More potential energy it gets, the stronger the bond must be. But yeah, those basics, it's actually in your textbook. You can go through it. It's listed. But yeah, let's answer the question. So, bond energy, energy needed to break 1 mole of a compound molecules into separate atoms. So the energy needed to break 1 mole of a compound's molecules, right? Now, which curve A or B represents the formation of a double bond? Right, in this case it would be A, right, and we need to know when the bond order increases, right, the bond length decreases and the bond energy increases. So you see there, that bond length was 148 for B, bond length for A is 121. So the bond length decreased from 148 to 121, and therefore the bond energy increased. So that is how I know that the double bond is formed, because the bond order increases to get that right. So I hope that makes sense. Bond length decreases, bond energy increases, therefore my bond order increases. Right, and they say write down the bond length of curve B, that is 148 picometers, right? God bless. Bye.